Today I'll be demoing StickyBrain. StickyBrain is a Mac desktop app that uses LangGraph agents that execute in parallel to help you brainstorm and problem solve without any prompting. So while you're typing in a sticky note, StickyBrain will autonomously gather information from your old Mac Stickies that is related to whatever you're currently typing using retrieval augmented generation. It will also generate web search queries that it think would benefit what you're brainstorming about, and it will autonomously gather information from the internet and do research without you having to ask. Here's a preview of it in action. I'm hungry. What should I eat? We've got our nice loading spinners, and we've got an incremental load in, so panels will come in one by one as they complete. And so it came back with a concise two-sentence synthesis at the top. It says, you often eat rice and chicken plates, very true, frozen vegetable food, grapes, blueberries, sweet potatoes, celery, and some other things. And that's very accurate. That's definitely things that I like to eat. For my web browsing, I found that Hanshin Poka in Koreatown serves golden fried chicken and pork belly pancakes until midnight, and then it offers tacos los poblanos as another spot in LA. It searched most unique late night eats LA versus Atlanta, and recipe generators that recommend meals based on fitness goals. And the reason it knows about LA, Atlanta, and that I'm into fitness is because I wrote those things in my personal goals. And so it's offered tailored suggestions from my own stickies and from the internet that are specific to what I'm currently typing and to my overarching personal goals. So let's talk about the way this all works and the flow. So in our left column, we have our RAG pipeline. In our right column, we have our web search flow. Right here, we have user goals, and these persist between sessions. Here in the README, we have the diagram that shows the flow of the LangGraph nodes. So when the user is typing in a sticky note, there's an input node that is monitoring the file states in the stickies directory and watching for the last modified sticky file. And then it extracts the most recently typed paragraph from that sticky, and then it kicks off parallel execution of two flows. The web search pipeline and the RAG pipeline both run in parallel. We embed all of the sticky notes in paragraph-sized chunks into a Chroma vector database using the OpenAI text embedding 3 small model. And then once those embeddings are in the system, all subsequent queries will run quickly. And so you can click the Run Embeddings button in the UI to make sure that those embeddings run when you first start up StickyBrain. Once the user has typed a paragraph and pressed a period or some punctuation, relevant snippets will be retrieved from the Chroma vector database using retrieval augmented generation, and we'll find the first 10 top-ranked similar vectors. So there's an embeddings node, there's a retrieval node, there's a filter node, and then there's a summarization node. And so in the summarization, GPT 4.1 creates a focused summary of the snippets that were retrieved from the old sticky notes. In parallel with that flow, we have the web search pipeline. A LangGraph node generates relevant web searches, 3 targeted web search queries that it believes will help the user based on the personal goals that have been provided in the prompt and what the user has currently typed. Then it executes those 3 web search ideas. GPT 4.1 then gets a new prompt where it sees the URLs and the preview text from all of the web search results, and it chooses 2 URLs that it believes are the most relevant to the user's personal goals and what the user is currently typing about. We scrape those top 2 web pages, we convert the HTML into text, and then we summarize those using another call to GPT 4.1. And so we've got these 2 flows in parallel, and both of those outputs of those 2 flows are passed into the StickyBrain synthesis node, which performs a concise summarization into 2 sentences, and there's some prompt engineering to make sure that the summary is very detailed and concise and includes concrete and valuable information rather than being full of fluffy language. And so we've got 11 LangGraph nodes that are used with 2 flows that run in parallel. Let's do another example. So I have an app I'm working on called Opus Melody. It's a music generation software, and I want to develop new features for it. But I have so many ideas for features, and they're scattered through my notes. The sticky I have that has Opus Melody feature ideas, it's probably like 10 pages long at this point. So let's see what StickyBrain chooses as the features I should build based on what it knows about me. Microtonal software, that's a feature that I'm very excited about. I'm glad that it picked that out. A melody chat voice mode, very cool. A Vocaloid trained on the user's voice. So these are all my old writings that have been scattered out throughout this long 20-page sticky. These feature ideas have been plucked out. And then it's also done some web research for me. And let's see what the synthesis says. It found integrated automated AI music production and gamification features like points, rewards, or interactive minigames. Okay, I'm not a fan of that idea, but that makes sense because it came from the internet. But it's nice to see a contrast between some autonomous web searches and my own ideas. This is definitely a good jumping off point for my brainstorm process here. Let's take this a little bit farther. So now I'm continuing my brainstorm, and I'm honing in on the microtonal feature that I want to build. Very cool. So it reminds me what the mission of my software is, to design songs that can't be constructed with existing technology. And I like that it plucked that detail out, because microtonal software would be a pretty unique feature. And a very cool insight was found through the web browsing. From my web browsing, I found that you can generate custom timbres for each microtonal tuning by creating loopable wave files with overtones aligned to the tuning. I don't even know what that means, but it name-dropped a specific package or something, and that's very cool. So this is a fun brainstorming tool. It layers in AI intelligence without me having to do much prompting. I'm really just going through my normal brainstorming process here in a sticky note, and it's coming up with the prompts on its own.